This is the fourth video on section 6.2, the derivative, and the material on this board is a little bit scattered, and so I have things numbered 1, 2, 3, 4 in the order that we'll look at them. Okay, so here we're going to look at example 166. Now we have a polynomial of 3 variables. We have a third degree polynomial of 3 variables. We're going to prove that it's differentiable and find the derivative. We're going to start the proof that it's differentiable in this video, and we will finish it in the next video because I don't have room on the board to do this. So we start by calculating the partial derivatives. So we have the partial derivative with respect to x, the partial derivative with respect to y, and the partial derivative with respect to z. And then we start by writing our limit. Now this is a function of 3 variables. So instead of just the point hk going to 0, 0, as with the previous 2 examples, we have the point hkl going to 0, 0, 0. We have a function of 3 variables. And then we have g of a plus h, b plus k, c plus l, minus g of a, b, c, minus this expression here. Now that we have a function of 3 variables, we have 3 partial derivatives. Partial derivative with respect to x, evaluated at a, b, c times h, plus the partial derivative with respect to y of a, b, c times k, plus the partial derivative with respect to z of a, b, c times l. So this is just the limit that we check to see if our function is differentiable or not. I'll step out of the frame for a moment and focus your attention right here. So this next step goes all the way across. So this is part 1. Now part 2, I'm going to let you simplify this algebraically on your own. If you have questions, ask me in class. So this whole thing simplifies down to this limit right here. Limit is hkl goes to 0, 0, 0 of this. And so now what we want to do is prove that this limit is actually 0. So what we're going to do is we're going to use a squeeze theorem. We're going to look at the absolute value of this term. And what we're going to do is we're going to squeeze this between the opposite of the absolute value and the absolute value. So here we take the absolute value. Notice I do not have an equal sign there. I'm not claiming at this point that these limits are equal. They are, but I'm not saying it yet. So we take the absolute value, we multiply by -1. This expression is less than or equal to this one. So all we have done is we've removed the absolute value and the -1. But this thing is less than or equal to its absolute value. So all we have done is we've said this expression that we're trying to simplify is stuck as a lower bound -1 times its absolute value, and as an upper bound its absolute value. So we have this thing we're trying to calculate the limit of squeezed between these two things. So our strategy in the next video will be to show that this limit is 0. If this limit is 0, then that means the limit of its opposite is also 0. And so the limit of the thing that we actually want right here is stuck between something going to 0 and something going to 0. So we can use a squeeze theorem to prove that the limit is 0 if we can prove that this limit here is 0, and we'll do that in the next video.